In the coming decade, we stand on the brink of a revolution. A revolution that will redefine how we think about intelligence, human or artificial. As we delve into this future landscape, let's peel back the layers and uncover some of the foundational theories that are shaping our understanding. Imagine a world where machines can learn like humans do. Where they not only mimic but also innovate in ways previously thought impossible. This isn't just science fiction, it's grounded in complex scientific theories that challenge everything we know about intelligence, learning, and consciousness. At the heart of this transformation lies something called artificial neural networks, ANNs. These are systems designed to mimic the structure and function of biological neurons. They work by creating layers upon layers of interconnected nodes, much like how our brains process information. Each node in these ANNs can learn from data inputs and adjust its connections based on feedback, much as a child learns new skills. But there's more than just mimicking biology at play here. These systems are also driven by complex algorithms that enable them to recognize patterns, make predictions, and even generate content. This is where the theory of deep learning comes in. Deep learning involves using multiple layers of ANNs to extract features from raw data automatically. It's like giving a machine the ability to see, hear, and understand the world around it, just as we do. Now, let's talk about reinforcement learning. Imagine if machines could learn by trial and error, just like you or I might. Reinforcement learning is all about that process. These systems are rewarded for making good decisions and penalized for bad ones. Over time, they optimize their actions to maximize rewards, essentially teaching themselves through experience. And then there's the concept of transfer learning. Think back to when you first learned how to ride a bicycle. You might have started with training wheels but eventually mastered it without them. Transfer learning works similarly. Machines can take knowledge gained in one context and apply it to another. Much like carrying in the next decade, machine intelligence will continue to transform our world. As we step into this future, understanding its roots is crucial for navigating what lies ahead. Let's dive deeper into some of the key scientific theories and background context that are shaping the landscape of AI. Firstly, consider how humans have always pushed boundaries with technology. From the invention of fire to the internet, each leap has fundamentally changed society. Today, we're on the cusp of another monumental shift, machine intelligence. But what makes it so different from previous technological advancements? Machine learning is at the heart of AI's progress. Imagine a system that can learn and improve without being explicitly programmed. This ability stems from algorithms that mimic how our brains process information. Take for example, neural networks. These are layered structures designed to simulate human brain functions. Each layer processes data in increasingly complex ways, much like how we recognize patterns or solve problems. Another critical concept is deep learning. It's a subset of machine learning where artificial neural networks can learn from vast amounts of unstructured data like images, sound, and text. This capability has enabled machines to perform tasks that were once thought impossible for computers, such as recognizing faces in photos with near-human accuracy or generating human-like speech. But it's not just about the algorithms, it's also about how we interact with these intelligent systems. Imagine a world where you can have natural conversations with your devices, where they understand context and nuance. This is made possible through natural language processing, NLP, which allows machines to interpret and generate human-like text. The ethical implications of AI are equally profound. As these technologies become more advanced, questions arise about privacy, bias, and accountability. For instance, how do we ensure that algorithms don't perpetuate existing social biases? How can we build systems that respect individual privacy while still delivering valuable services? Moreover, the role of humans in this future is evolving rapidly. Just as machines are becoming smarter, so too must our skills in the next decade. We're on the brink of something extraordinary. Machine intelligence is about to transform our world in ways we can barely imagine today. Let's dive deeper into some key scientific theories that will shape this future. First up, neural networks and deep learning. Imagine a vast web where information flows like water through countless interconnected nodes. That's what happens inside these sophisticated algorithms. Each node represents a piece of data, and the connections between them represent how those pieces interact. These networks learn from massive amounts of data to recognize patterns, make predictions, or even generate new content. But here's an interesting twist: scientists are now creating hybrid models that combine deep learning with symbolic reasoning. Traditionally, neural nets were good at processing raw data but struggled with logical reasoning tasks. Symbolic systems, on the other hand, excel in understanding rules and making deductions. By merging these two approaches, we get a system that can handle both kinds of problems, like a superintelligent assistant that not only learns from experience but also understands what it's learning. Next, let's talk about reinforcement learning. This is like teaching an AI by giving rewards or punishments for certain actions. Think of it as playing a video game where you earn points for making the right moves. The machine keeps trying different strategies until it figures out which ones give the best results. Over time, this process can lead to some truly remarkable outcomes. Another fascinating area is generative models. These are AI systems that create new content based on patterns they've learned from existing data. Imagine an artist who can paint a whole picture just by looking at other paintings. That's what these algorithms do, but with all sorts of media: music, text, images, and even more complex things like 3D designs. Now, let's explore the concept of explainability in AI. As we rely more on machine intelligence for critical decisions, understanding how and why an algorithm makes a certain choice becomes crucial. Researchers are working hard to develop methods that in the coming decade, as we dive deeper into the realm of machine intelligence, it's crucial to understand some fundamental scientific theories that will shape our future. Let's explore these concepts with a sense of anticipation and awe at the technological advancements on the horizon. Firstly, let's talk about artificial neural networks. These are computational models inspired by the human brain's structure and function. Imagine each neuron in your brain communicating through synapses. Now imagine millions or billions of such neurons interconnected to form complex patterns. In AI, these connections mimic how a computer can learn from data, much like you might recognize a face after seeing it once. Neural networks are crucial because they enable machines to perform tasks that require human-like judgment and perception, tasks that were previously the exclusive domain of organic intelligence. For instance, consider image recognition or natural language processing. These systems have already outperformed humans in some areas, but as we develop more sophisticated architectures like deep learning, their capabilities will expand exponentially. Moving on, let's delve into reinforcement learning, a subset where machines learn to make decisions based on rewards and punishments. Think of a video game character that learns the best strategy by trying different actions repeatedly until it maximizes its score. Similarly, AI can explore vast spaces of possibilities to find optimal solutions for complex problems. This approach has been particularly successful in areas like autonomous vehicles or even mastering games like Go. Now, consider deep reinforcement learning, a blend where machines not only learn through rewards but also from the environment and past experiences. Imagine an AI system that learns how to play a video game by observing others, then improving its own gameplay over time without explicit human guidance. This combination of learning methods opens up endless possibilities for innovation across various industries. Another key concept is generative adversarial networks, GANs. GANs consist of two neural nets, the generator and the discriminator. The generator creates new data instances while the discriminator evaluates them against real ones, providing feedback to refine the output. This system pushes both. In the next decade, machine intelligence will transform our world more dramatically than ever before. As we stand on the brink of this new era, understanding the underlying scientific theories is crucial to grasping what lies ahead. Machine intelligence relies heavily on algorithms and neural networks, mathematical models that mimic the structure and function of the human brain. These systems learn from vast amounts of data, allowing them to perform complex tasks such as recognizing patterns or making predictions. The key here is not just raw computing power but sophisticated techniques like deep learning, which enable machines to improve their performance through experience. One fascinating development in this field is reinforcement learning. Imagine a robot playing a video game. It learns by trial and error, receiving rewards for successful actions and penalties for mistakes. Over time, the machine adjusts its strategy based on these feedback loops until it masters the game. This same principle can be applied to countless real-world scenarios, from optimizing energy consumption in buildings to managing traffic flows. Another area gaining significant attention is generative models. These algorithms create new data that resembles existing datasets but contains novel variations. Think of them as creative partners. Imagine an AI generating unique music compositions or even designing innovative architectural structures based on human preferences and constraints. Quantum computing, too, holds immense promise for accelerating machine intelligence research. Traditional computers use bits to process information in binary form, zeros and ones. However, quantum computers utilize qubits which can exist as both 0 and 1 simultaneously thanks to principles like superposition and entanglement. This unique property allows them to perform complex calculations much faster than classical machines. But the true power of machine intelligence lies not just in its computational prowess but also in how it interacts with humans. Natural language processing, NLP, is at the heart of this interaction, enabling seamless communication between people and AI systems. Imagine having a conversation with your smart assistant where you can ask for detailed information about historical events or even receive personalized advice based on your unique preferences. Moreover, as we stand on the brink of a new decade, it's hard not to feel both excitement and a touch of uncertainty. The world has changed drastically since machine intelligence first began weaving its threads through our daily lives. But what does this mean for us as humans? How will AI continue to evolve in ways that reshape our reality? Imagine stepping into a future where machines think like you do, learn like your children, and even dream like your wildest imaginations. This isn't just science fiction, it's becoming more real with each passing day. Scientists are now exploring theories of consciousness in artificial entities, thinking about how to create AI that not only functions but feels. In 2019, researchers at Stanford University proposed a framework for understanding machine intelligence through the lens of human-like reasoning processes. They suggested breaking down complex tasks into simpler steps similar to those used by humans. This approach could lead to more intuitive and adaptable AIs capable of handling unforeseen situations with ease. But what about ethics? As AI becomes more advanced, so does the necessity for ethical guidelines. In 2021, a group of international experts drafted the Global Charter on Ethical Development of Artificial Intelligence. It outlines principles such as transparency, accountability, and fairness to ensure that AI serves humanity rather than poses a threat. Then there's the question of employment. As machines take over certain jobs, what happens next? Economists predict that while some roles will disappear, new ones will emerge, ones we can't even imagine yet. It's crucial for society as a whole to adapt and retrain workers so they can thrive in this changing landscape. Another fascinating area is the integration of AI with human brains. In 2017, scientists successfully implanted neural interfaces that allowed users to control robotic arms simply by thinking about movement. This opens up possibilities not just for those with disabilities but also for enhancing cognitive abilities and even boosting creativity. However, these advancements come with challenges. Privacy concerns loom large as the future isn't coming, it's being built. Subscribe to stay ahead.